Okay, so we had covered some of the basics of given either an equation of a circle and finding the center and radius, or given the center and radius and finding the equation, right? So, well, I wrote formula here, equation, formula, whatever. So x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. I'm going to take it a step further now because you're not always just given the center and the radius, right? You might be given other information. So the first example, well, both of these examples I gave the center again. And in the first one, I give a point that it passes through. And the second one, I only shared that it's tangent to the y-axis, which means tangent means it touches the y-axis. Okay, I'll draw a picture to show that. You could have other information, such as maybe just the endpoints of a diameter or something. So let me draw a quick sketch, though. It's not really necessary for either of these, but I want to show kind of where we're going. All right. So the center here is 1, -5. So rough sketch, right? 1 and then down 5. It's somewhere here. There's my center. And it passes through, let's switch colors. There's my center, and it passes through -1, 1, so somewhere, up here. Looking at that, I can't really visualize kind of like, what is the length of this radius, right? If that's passes through there and here's the center, then the circle, again, rough sketched, but looks something like that, right? I know to write this equation, I need the center, which I have. Here's h and k, awesome, done, right? But now I need r. So that's where we're at with this one. So what else I was saying is maybe they don't give you the center at all, right? Maybe they give you two endpoints, this endpoint and this endpoint, and that's on the diameter, let's say. Remember, the radius is kind of from the center to any endpoint of the circle. The diameter is the whole length. If they gave you that instead, right, you need to find the center by using the midpoint formula. So each problem can be a little different. I'm going to go ahead and erase that because we're not doing that. Right, but it is, an option. Let's draw that y back in there. Alrighty. Well, the radius, we talked about this in class, but we could picture like a triangle in here, right? A right triangle, and do the Pythagorean theorem. The shortcut for that is just use the distance formula. Either way you're comfortable with, it's fine. I would just prefer, becoming familiar with the distance formula because it will save you some time, right? I don't want to sketch this, especially what if we had weird values like, I don't know, square root of 2, comma, and a fraction, 1/2. I don't really want to visualize where that would be and do the Pythag. Anyways, distance formula. Subtract our x's. It doesn't really matter the order. I'll call this one x2. So -1 subtract 1 squared plus, I'll call this one y2. 1 minus a -5, so 1 plus 5, right? Minus. So therefore that distance, or the radius that we get, is equal to the square root of, let's see, -1 is -2 squared plus 6 squared. So we get 4 plus 36, which is 40. Now, you should always reduce, but I'm going to point out here the equation has r squared, right? The equation of a circle is r squared. So if I reduce this, using the tree, and then I square it, I'm going to get right back to this result. So let's go ahead and just use the equation of a circle. We have x minus the center h, which is 1, squared, plus y minus the -5, so y minus, right, so plus 5 squared, equals r, which is square root of 40 squared. But a square root squared is simply 40. So our final result, remember, you are not expanding x minus 1 squared. You leave it in this form. The reason you do so is I can tell right away this has some value x squared, right? And then some value of y squared equals r squared. If it's in that form, I know it's a circle. If I expanded all this, it might be harder to tell. Okay. All right. Moving on. The next example, again, you don't have to graph it. I'm going to graph to kind of show you what's going on here, but the center is negative 5, 3. So back 5, down 3, somewhere here, right? And it is tangent to, it touches this y-axis. So here's my center, and it touches here. Okay, so tangent means it doesn't cross, it just touches there. Okay. Well, without the drawing, we could do this, but this picture helps me visualize exactly what's going on. Because I can just see here, I was at negative 5, right? The center was negative 5. Oop. I don't know why I went down 3. We could quickly change this to a negative 3, but I'm human. I make mistakes. I failed on my graph. I'm sorry. Let me fix that really quick. Negative 5, positive 3, negative 5, positive 3. My bad. There's my center. Okay, and then it's tangent to y, so it touches there. It's the small things that'll get you, right? Same with me. All right, now I could still visualize same result for the radius, but that center was definitely off, right? The radius here, from here to this y-axis, I know that length is 5. I could see it because the x was negative 5, right? So if this value here was negative 5, 3, the center, to get over to the y-axis, I had to go to 0, 3, right? Which I had to go right 5 units, so therefore the radius is 5. Without any crazy formulas, just a quick kind of visual, we can solve this problem. X minus h, so x minus, right, this is h, this is k, minus a negative 5 becomes plus 5, plus y minus 3, right, that's k, squared, equals r is 5, 5 squared. So again, the only thing we ever need to do is like simplify this if possible, which, 5 squared is 25, so might as well do that. And there we go, x plus 5 squared plus y minus 3 squared equals 25. Done. Hopefully you find circles easier than they appear. They're quite intimidating, right, to look at. But once you see the formula or the equation and I'm going to get rid of that. It's an equation of a circle, right? And you know how to use it, pretty straightforward, not too bad.